All right, continuing with the definition of measures of center, um, we're going to progress now to looking at continuous data with either small or large sample sizes. Now, when dealing with measures of center of data sets, I've broken it down into three separate cases. The first case, which is the one that we just looked at, is when you're dealing with a discrete data set. So a data set composed of counting numbers and with a small sample size. And I call this like a textbook case. All right. So it's simple, easy to work with so that you can understand and comprehend the idea. But we need to kind of progress from that to cases that are not always ideal, ones that are reflected more in real world circumstances. So now we can move on to the second case, and that's instead of having discrete data set, you have a continuous set of data. So continuous datums are measured datums, and most of the time they'll have some kind of decimal point in them. In this second case, where you've got datums with decimal points, you can have either small or large sample sizes. And this is most likely what you're going to be seeing in your student project. Now, the third case that I've identified, case three, again, you're dealing with continuous datums, datums that are measured. But instead of having access to the raw data itself, instead of having access to the numbers, instead, all you have to work from is either a frequency distribution table or a histogram. That's it. You only have maybe a picture or a table to work off of. And so, then you can have either a small or large sample size. But, this second case is where the data set is available and you can work with it. This one is where the data set is unavailable and you don't have it. So all you have to work from is going to be a frequency distribution table or a histogram. And we'll get into each of these three separate cases. So kind of as a review of case one, which is kind of what we just did. So that's where you're working with a discrete data set and a small sample size. So here you can see our random variable X. This is our data set here. And, the mean for this comes out to be 7.875. You could use, the previous example as a model and calculate this yourself. This is the formula for calculating the mean. If you're going to use the Texas Instruments or the NumWorks calculator, you can use the function one variable stats or enter it into your NumWorks calculator and look at the stats tab. It'll just give you that number. The median, in this case, is going to be 8. And I labeled it here, so the median is underlined. So the median is 8. This is the value between the 12th and the 13th datum because our sample size is even. And there's also a calculator function, the same one variable stats, and the stats tab on the NumWorks calculator, which will also give you the median. And then the mode. So in this case, the mode is 9 because it's the value that occurs with the highest frequency. So you can see here is the datum 9, and it occurs 8 times, so more than anything else. Now the mode, don't think the Texas Instruments calculator will provide that, but the NumWorks calculator does in the stats tab. So you can kind of get the mean, median, and mode, the three measures of center, relatively easily when you're dealing with a discrete data set with a small sample size. Now, moving on to case two. Here you're dealing with measured data. This will be data that most often has decimal points with either small or large sample sizes. Again, this is what you're going to see in your student project. So in this case, this is where the data set is given, but the datums are continuous quantitative data. So, if this were your random variable and this was your data set, you can see that these datums, are 234.41. So they have some decimal places in them of accuracy. So these were measured. Students will use Microsoft Excel or Google Sheets to get the first two measures of center. So to get the mean and to get the median. Okay, the software is going to do that for you. But you will not be able to use the mode function on Microsoft Excel and Google Sheets. It'll give you the wrong answer. So instead, you're going to be creating frequency distribution tables or histograms of your data, and you're going to use a formula for the arithmetic mode. Okay? The equation for the arithmetic mode is what you're going to be using to calculate the mode of continuous data. All right, and I'll get into an example of that. And then the third and final case, okay, is, again, when you're dealing with continuous data, but you don't have access to the data set, you only have a frequency distribution table or a histogram to work from. So you can see here, the data set is not given. Instead, you have this frequency distribution table, or you have a histogram. This is what you have to work off of. So in this case, if that's all you got, then there are three different equations for calculating the mean, the median, and the mode. And I just call these the arithmetic mean, the arithmetic median, and the arithmetic mode. And so you can see that these formulas are a little bit bigger than the other ones that you saw for discrete data sizes. And please try not to be intimidated, by these equations. A lot of the values, what these represent, you can just kind of see in the picture. Okay. So don't be intimidated by that just yet. I'll get into that and I will explain it here in a minute. Okay, so this is a good place to stop. Again, come back up to the top. When it comes to measures of center, I've broken this down into three distinct cases. Case one is where you're going to be able to use your Texas Instruments or your NumWorks calculator quite easily. Case two is what you're going to be looking at when doing your student project. And case three is really if outside this class, you're working with, biology or chemistry or whatever, and you have a table or a histogram of data, these formulas will let you calculate the three measures of center for that data just based off of a picture or a table. All right, thank you. Let me know if you have any questions.